Alright, here I want to show you how you can solve this question that you are looking at on the screen, which has to do with link mechanism. But before I move on to solve the problem, I want to tell you that you should subscribe to my YouTube channel, share my videos with your friends who are technical drawing students, and also like the channel, make comments, can ask questions, and whenever I get your question, I will respond to your question. I'll give answer to your question whenever I see it. And then make sure you press the notification bell so that whenever I upload a new video, you'll be notified. It's very, very important that you press the notification bell so that you can get information about the new video that I may upload. Now let's look at the question. The question says that the crank mechanism shown below consists of a crank AB which rotates about center A and an arm CD which oscillates about point D. The link BC connects the crank and the arm. Plot the locus of the midpoint P of the link BC for one complete revolution. So what is the question telling us? Now, this is the crank that it's rotating about this point. This is the central point. So this is rotating, and then we have a connecting rod that is moving as this is rotating, and then there is an arm CD which is moving or oscillating along this arc here, along this arc. So we are now asked to plot the locus of point P for one complete revolution of the crank, So looking at what we have here, I believe you can see the dimensions. Distance of the center of the crank from this point D is 80 millimeters, and then this point D, the distance of point D, or this line upon which D is located, its distance from the center of the circle is 15 millimeters. And then as we have here that distance AB is 50 millimeters, distance BC is 80 millimeters, and distance CD is 75 millimeters. So all these things are what we are going to put in our drawing. So just look at the way I'm going to do it. It's very simple. Just pay attention to the way I'm going to do it. So the first thing that you need to do is to draw the horizontal center line. So draw the horizontal center line, and then you draw the vertical center line. So the next thing is, so the diameter of the crank is 50, okay, the radius of the crank is 50 millimeters. So you take a radius of 50 millimeters with your compass, and you put it here and draw a circle like this. Okay, now divide this circle into 12 equal parts. Divide the circle into 12 equal parts. Okay, so I'm dividing the circle into 12 equal parts. So, and then we are going to number, but the numbering, you have to take note of this point. So this point that we have, which is point P, point B on the circumference of the circle, is very close to this vertical line. So meaning that I'm going to use, this is the point. This is going to serve as point B now. This is point B, and this is center A. So this will be 1. I'm going to number this as 1, and this will be 2. This is 3. This is 4. This is 5. This is 6. This is 7, 8. This is 9. This is 10. So this is 11, and this is 12. So you have to number them as we have here. So the next thing we are going to do is that we are going to join the points together. So this is what I'm saying. So I'm going to connect 1 and 7 together with a straight line. Connect 1 and 7 with a straight line. Then I'm going to connect 6 and 12 with a straight line. 6, 12 with a straight line. Then I'm connecting 9 and 3 with a straight line. Then I connect 10 and 4 together. Okay, all right. So having done this, so the next thing that we are going to do is that I will still need to, okay, I'm going to take a measurement of 15 millimeters down from the center of the circle here. So take down 15 millimeters and draw a horizontal line from here. Draw a horizontal line to this side. So as we have in the question, so that the distance of the center of the circle from point D is 80 millimeters. So that means I will take a measurement of 80 millimeters from here. This is 80 millimeters. Then I will draw a vertical line up. So just a small vertical line. So this is point D. So this is where we have point D now. All right. So and then we have that CD is 75 millimeters. So what you need to do is to take your compass, take a measurement of 75 millimeters on your ruler like this, and then you put it at point D and you draw an arc. So 75 millimeters on your ruler like this, put it at point D and you draw an arc. So this is the arc. So you draw an arc like this. Okay, now having drawn this arc, so we need to locate point C. We need to locate point C. We have located point D, so we have drawn the arc. As we are told that CD is 75 millimeters, so distance from any point on this arc is 75 millimeters. Now we need to get point BC. So we have point B here, so we need to locate C on this arc. So we are told that BC is 80 millimeters. So you take a measurement of 80 millimeters on your ruler. Then you put it at point B here and you make an arc on this arc like this. So this point is point C. So this is point C. Oh, okay. So the next thing we are going to do is that, so we are going to join this point together, point BC. So we join them together with a straight line like this. As we are told that P is the midpoint of BC. P is the midpoint of BC, as we have in the question. Plot the locus of the midpoint P of the link BC. So P is the midpoint of BC. So if BC is 80 millimeters, P will be 40 millimeters from B and 40 millimeters from C. So I'll just set my ruler like this and take a measurement of 40. So this is 40 millimeters. So this is point P now. So this is point P. So here we have what? We have the first P. So the next thing we are going to do is that with that same 80 millimeters as we are told, so with that same 80 millimeters, so with the same 80 millimeters, you put the pinpoint of the compass at point 2 and you make an arc on this arc. Then you draw a straight line from point 2 to this point on the arc. Then you take a measurement of 40 millimeters from here. So this is another point P here. Then again, so with the same 80 millimeters, so you do it one by one. Same 80 millimeters, make an arc here. After putting the pinpoint of the compass on point 3, then you draw a straight line. Alright, so I'm going to do the same for the rest to get the rest of the point. So here you take 40 millimeters from 3. So this is another point P here. This is another point P. So I'm going to do the same for others. Then when I get all the points, I will come back and show you the shape. Alright, all the points have been obtained. All the points have been obtained. So the next thing I'm going to do now is to join them together with the use of my French curve, and I would like you to see how I'm going to do it. It's very simple. So you just need to learn how to make use of your French curve. It's very simple to use. So some students do find it difficult to use, but it's very simple. So all you need to do is to set the edge of the curve along the point. Okay, so you need to rotate it so that the curve can come out. So you can join two together. So like these three, I can take them together. By adjusting the French curve. So I'm able to join them together. So I can also join these three together. Okay, I'm able to join these 4 together. Alright, so next is this. Alright, so this is the shape that we are expected to produce. So this is the shape. So it's as simple as I've shown you here. So all you need to do is to do your own. So just practice it. So the question is very simple. Anything that has to do with link mechanisms is very simple. What you need to do is to try to understand the question. So look for more questions on link mechanisms and practice. I've solved many questions on link mechanisms. So you can take the questions that I used and solve them. And don't forget, as I said, that you should subscribe to my YouTube channel, share the videos with friends who are technical drawing students. So like the videos and also make a comment or you ask question, and I will respond to your question as soon as possible. And don't forget to press the notification bell so that whenever I upload a new video, you will get notified. Thank you. God bless you.